So another corollary that goes along with inscribed angles is that if we have inscribed angles of a circle that intercept the same arc, all right, the same arc. So you've got a couple of different inscribed angles, but they're actually intercepting the same arc, or are subtended by the same chord or arc. Then the angles are congruent. Let me point out what that's saying here. If we have arc AB, notice that arc AB is the intercepted arc of angles ACB and ADB. Okay? Also, there's a third angle in there, which is angle AEB. Well, what we know then is since those angles intercept the same arc, then each of those angles are going to be equal to each other. All right, and this is pretty well drawn here. If you look at those angles, they actually do look like they are equal. This is a pretty good skill drawing of that. Okay. So if we look here to find the measure of angle ABD, well, let's find angle ABD. And again, notice this is angle ABD. So for angle ABD, if we want that angle, the intercepted arc is 86 degrees. So take half of that 86 degrees, and I'll just write this down here. That would be 43 degrees. All right. To find the measure of arc, there should be an arc here, BC. Okay, well, here's BC. That's kind of a strange looking diagram, but it is what it is. If the measure of angle BAC is 60 degrees, then the measure of arc BC would have to be, that's right, 120 degrees. Well done. So, we can apply this. Here it says an art student turns in an abstract design for his art project. Given all this information, and actually kind of looks like a girl if put two eyes here and a mouth. And there's her hair. Find the measure of angle DFA. So now this gets to be a little bit tricky. Let's take a look at what we're given. We're given that the measure of this angle right here, DCF, has a measure of 33 degrees. So that is that entire angle. We are to find DFA. So in order to find that, well, we don't have any information about really anything there. But since we have the measure of this angle, we probably would be able to find maybe some measures, if you follow my marker here, of these other angles in this triangle. Well, notice that this 164 degrees is actually the measure of this arc right here, arc BC, which is intercepted by this angle BDC. So if the measure of this arc is 164 degrees, then that would mean that the measure of this angle is 82 degrees. That's a 2. Okay? Leaving us with, for this angle right here, what we can do is take 82, add that to 33, that would give us 115, and let's subtract that from 180. Now, I'm taking a two-step process when, if you remember something that we applied earlier this year, we probably could be done with this right now. Now, the measure of this angle, I'll just draw a little arrow right there, would be 65 degrees. Keep in mind that what we are to find is the measure of DFA. Okay, what we've done so far is we said within this triangle, this angle is 33 degrees, this angle is 82 degrees, so that leaves us with 65 degrees for that third angle. Well, with us having to find DFA, goes to one of my favorite things, these two angles are supplementary. So what we can do is, I'll do this in red, subtract that 65 from 180, And what that'll give us is we go right back to the 115. What I was alluding to earlier is we talked something much earlier in the year about the exterior angle theorem, which stated that the measure of this angle, which is an exterior angle to this triangle, the measure of that angle is actually equal to the sum of this 82 and 33. So you get 115 degrees. That will be the measure of angle DFA.